Hello, can you hear me? Eugene, if you can hear me, kindly say yes, you can.
Yes, I can hear you.
Okay. Today, Faith won't be joining. She's sick, so we'll start. The others will join as we go along. And let's continue. So I want us to finish this chapter today and then start chapter 3. So we were left with the input function. The input function is used to ask for input from a user. We have seen the print function is used to print output that is from the computer to you. It's used to display an output. But now we have something known as the input function. This input function is used to ask for user input. For example, you want users to key in their values, for example, their names. You will use this function to do that. It is able to read data entered by the user and return the same data to the running program. So it reads data entered by the user and then returns the data in the program. For example, here we print tell me anything, and then anything. We use this function input, and then we print anything, really? Yes. So when we go to the practicals, we will see how it is used. So the input function with an argument. The input function can do something else. It can prompt the user without any help from print. So for example, in the first example, we saw that we used print to tell the user to tell me anything, and then we use the input function. But here, as you can see, the input function can be used without the print line, like here, input tell me anything. When you do that, it will still do the same, it will still run the same way it ran when we used the print function. Note, here the input function is invoked with one argument. It's a string containing the message. So here the input function has a string that contains the message. The message will be displayed on the console before the user is given an opportunity to enter anything. So this message will be displayed on the console before the user enters something. The input then does its job. Okay, the result of the input function. The result of the input function is always a string. So for when you enter something using the input function, you will always get a string. For example, here, when you enter a number, it will always be a string, even though it's supposed to be an integer, but it will be a string. Everything that you enter using the input function will always result into a string. This means you must not use it as an argument for any arithmetic operations. So you should not use the input function as an argument for arithmetic operations. 1 minute. Okay, here we can try and run the input function and see. Let us run this first. Okay, let me first comment on this And then we run this input function and see what it gives us. As you can see here, it is telling us to enter a number, 20. Yeah, okay, now let me remove the comments and see. It is supposed to give us an error because we have said the input or the results of an input function is always a string, and you can't find the power of a string. So it will give us an error. Let us run and see. 20. Yes, as you can see, it has thrown an error here. This is the error. Typecasting. So, for example, you want a user to input an integer What do? That is what we call typecasting. You change the string that is entered by the user into an integer. If you want to change it into an integer or a float, you use int or float, as shown here. So the int function takes one argument and tries to convert it into an integer. If it fails, the whole program will fail too. The float function takes an argument and tries to convert it to a float. So if you want to convert a user input into a float, you put the float function before the input function here, like this. Okay, we can try and run this and see. As you can see, it has taken, I have inputted 20. So it has taken the 20 and converted it to a float. Then after converting it to a float, it has taken the power. It has taken 20 power 2.0, which is 400. Okay, so having a team consisting of the trio, input, int, and float, open up to. So this is just another example of typecasting. Here we want to change the string function to a float function, and we can try to run this and see. For example, here let me say 12 and then 15. So this float here has taken my input, which was a string, which was 12, and changed it to a float. This has also done the same with the 15. And then here we have done the operation, and then it has given us an answer, which is 19. We are finding the hypotenuse length of a triangle. String operators, introduction. Okay, so here we are going to do string operators. We remember how we concatenated strings. We said you can multiply strings. So you can also add strings. For example, we can try and run this and see what it will give us. Sorry, there was a type error. Okay, let me clear this and run it again. Yes, as you can see, it has done AB, AB. It has added AB AB. This is concatenating two strings. If you want to join two strings, you can use the plus sign. As we have seen here, we can also try to run this program and see what it will give us. This is also another example of concatenation. For example, you want to join 4 different strings. These are one, first name, space, last name, and then a full stop. Let's run this and see. May I have your first name? Let me say Mike. May I have your last name? Let me say Mike Julo. Okay, sorry about that. Let me run it again. Mike Julo. Thank you. Your name is Mike Julo. As you can see here, we have concatenated. We have concatenated and joined your name is, and then the first name here, Mike, and then space, which is this, and then which is between Mike and Julo, and then the last name, which is Julo, and then the full stop, as you can see. So that is one way of concatenating strings by using the plus sign. We can also replicate strings. We can multiply strings. For example, let me take examples of how you can multiply strings. You can take a string times a string, or a string times a number. For example, if we want to replicate the name James 3 times, you can do this example. If we have a string, we can name it James, and then we do print string times 3. Let's see what it will give us. As you can see, it has taken James 3 times. James, James, James. It has replicated James 3 times. So if you want to replicate a string, you can do this. This is one way of replicating a string. We can do another example. Let's say we have the R is equals to A. Let's say we want 5 A's. So it will be R multiplied by 5. As you can see here, it has given us 5 A's. So that is how you multiply strings, or you replicate strings. Type conversion. So for example, if you have a number or a value that you want to convert to a string, you use the str converter. You remember how we use the float and the int converter. So here we use the str converter to convert from one data type to a string data type. For example, I have a number. I have R is equals to 10. And I want to convert it to a string. So I will just come here and say capital R is equals to str R. And to know that it has been converted, I can just check its type. Type R. As you can see, this was an integer. Here, we converted it to a string by using this str function. And then after that, when we checked the type, you can see it is class str, which means it is class string. It has been converted to a string. We can try and run this also. So here we input a number, we input numbers which are converted to float, and then after inputting the numbers and the conversion taking place, the numbers are added and then multiplied by 0.5. Okay, and then a power of 0.5 is used on the addition. On the sum here, the sum takes place, and then the exponential. And then after that, it is converted to a string. Let's run this and see what answer it will give us. Let's use 12. Let's use 15. It has given us the hypotenuse length is 19. Is that. So this length, this hypotenuse length is currently a string because it has been converted to a string by this function here, this str. So this is a lab. I want you to go and try it. And also I want to ask, did you do the assignments? Kwame, I want you to go and do these labs. These are just practicals of what we have done so that you understand very well, and also you do the tests. You go do that lab, do those labs, you read this page, these key takeaways. This is just a summary of what we have done so far. And then after that, I want you to do the module 2 test, the module 2. I want you to do the questions and the test, these ones. Please go through the notes again. I want you to do this quiz and this test. Please go through the notes again before you do the quiz and the test for it to be easier on you. Eugene, sorry. Eugene, are you there?
I'm here.
Okay. Have you understood what I have taught so far before we move on?
Yes, I've understood.
Okay, so please go do the test.
Okay.
And the quiz and send me your screenshot, and also do those practical labs. I haven't done so that you can do them.
Okay.
Okay. So let's move on to module 3. In module 3, we will do Boolean values, conditional execution, loops, lists, list processing, logical and bitwise operations. So this is what we will cover in this module. And here we will start with Boolean data types, which we'll see when we move on. And then we will see relational operators, and then we will do decisions in Python, the if else, if else. And then we will cover while loops, for loops, and then how to perform logic and bitwise operation in functions. And then after that, we will cover lists and their applications. So, questions and answers. A programmer writes a program and the program asks questions. A computer executes the program and provides the answers. So a programmer will write a program and the program will ask questions, and then the computer will execute the program and the program will provide answers. The program must be able to react according to the received answers. Fortunately, computers know only two kinds of answers. Yes, this is true, which is 1, and then no, this is false, which is 0. A computer will never tell you, let me think about it. It will always tell you a yes or a no. Okay. To ask questions, Python uses a set of very special operators. Let's go through them. Comparison, the equality operator. So when you ask Python if two values are equal, you use two equal signs like this. Okay, so I want you to note something. When you use one equal sign, that is an assignment operator. For example, you want to assign the value 2 to a variable x. You will use this equal sign. And then the two, when you use double equal signs, they are used to do comparisons. For example, is 2 equal to 2? If you do that, you will use these two equal signs to compare. So this is a binary operator with left-sided binding. It needs two arguments and it needs two arguments and it checks if they are equal. For example, is 2 equals to 2? Here, the result will be true. Of course, 2 is equals to 2. Question 2, what is the result of the following operation? Is 2 equals to 2.0? Eugene, what do you think the result will be here?
False.
Okay, let's check. The answer is true. 2 is equals to 2.0. Here, is 1 equals to 2, the answer will be false because 1 is not equals to 2. I want you to note that 2 and 2.0 are equal. They're equivalent. Okay, let's move on. Okay, the equal to operator. The variable equal to operator compares to the values of two operands. We have done this. We can now try and see. Let's do this lab and see what it will give us. Okay, so for example, we have said when we assign a value to a variable, we should use one equal sign. For example, this we are supposed to use only one equal sign and not two. So when we run this, it will give us 0. Now, let us try to use two equal signs and see what it will give us. It's supposed to throw an error. Yes. It has given us an error. It is telling us var is not defined. That is because we are trying to compare var with 0. But when we run this, when we can, here, we can assign var is equals to 0, and then we can compare var and 0 and see what it will give us. It has given us true. That is because var is equals to 0. Okay, we can try and run this question. Is black sheep equals to 2 times white sheep? And see. It is supposed to give us an error because black sheep and white sheep has not been defined. Let us run and see. Yes, it has given us an error. It is telling us the name black sheep is not defined. We can run this and see what it will give us. This is supposed to give us true. This is the first one we did, and then this is supposed to give us false because 1 is not equal to 0. Yes, as you can see, the first one has given us true, and the second one has given us false. So, wait. I have seen there is not equal to here. Yes, there is an assignment called not equal to. Not equal to is the opposite of equal to. We have said equal to shows that two values are equal, but not equal to is used when two values are not equal. It is used to show two values are not equal. For example, let's use this var is equals to 1. Let's use this one. You can see it has given us true. That is because 1 is not equals to 0. So not equal to is the opposite of equals to. So when two numbers are not equal, it will give you true. But when two numbers are equal, it will give you false. Let's change this one to 0 and you'll see. As you can see, it has given us false. So not equal to is the opposite of equal to. Okay, here we can now start the greater than. You can also ask a comparison the question using the greater than operator. Is the black sheep greater than the white sheep? If it is greater than, it will give you true, and if it's less than, it will give you false. E.g., is 10 greater than 5? That the answer of that will be true. Or if 10 is 10 greater than 20, the answer there will be false. True confirms it, false denies it. And then there is also greater than or equal to. This is used to show that a value is greater than or it is equal to the other value. For example, is 10 greater than or equal to 10? The answer will be true because it is not greater than 10, but it is equal to 10. Or let's say, is 10 greater than or equal to 5? The answer there will be false because 1. Oh, sorry, the answer there will be true. Sorry. Is 10 greater than or equals to 5? The answer there will be true. Apologies. Because 10 is greater than 5. But if we use is 10 greater than or equal to 20, the answer there will be false because 10 is not greater than 20 and 10 is not equal to 20. And it is written like this. Greater than or equal to, and like this, sorry. That was the normal writing, but when you type it like this, a greater than sign and an equal to sign. Comparison of less than or equal to. The comparison of less than or equal to is the opposite of greater than. It shows that a variable or a value is smaller than another value or is equal to another value. For example, is 10 less than or equal to 20? The answer there will be true because 10 is less than 20, or is 20 less than or equal to 20? The answer there will be true because 20 is less than or equal to 20. Okay, so now we need to update our priority table. You remember the priority of operators where we said the unary operators are executed first, followed by the exponential, and then the multiplication, the divisions, and then the modulus. Then the addition and subtraction follow suit. The last table ended here. This is where the last table ended. But now, since we have done the greater than or equal to, less than or equal to, and is equals or not equals to, we will see in our priority table that the greater than or equal to, less than, and less than or equal to are operated first after the binary operations, those operations are executed next, and then they are followed by is equals to and not equals to. So this priority, you need to take a look at this priority table again. Knowing these things comes with practice. You won't know them in just one day. You have to look at it over and over again for it to stick. Yes. So this is your assignment. Go do this lab. I want you to practice so that you also understand, because if I practice alone, I will be understanding alone. I also need you to understand. Okay, let's move on to conditions and conditional execution. You already know how to ask Python questions. For example, is 2 equals to 2, is 2 equals to 2? That is an example of how to ask a Python a question. Okay, but you still don't know how to make reasonable use of the answers. You have to have a mechanism which will allow you to do something if a condition is met and not to do it if it isn't. So here, this is conditional execution. It's just like in real life, you do certain things or you don't when a specific condition is met or not. For example, if a teacher tells you, if you pass my exam, I will buy you a gift. So the buying of a gift is the condition. No, so the buying of a gift is the result, sorry, not the condition. And the condition is the passing of an exam. So if you pass an exam, you get a gift. If you don't pass an exam, you fail and you don't get a gift. So that is the same way we apply that same knowledge in Python. Trying to make such decision, Python offers a special instruction due to its nature and its application. It's called a conditional instruction or a conditional statement. So the instruction that you have given Python, like the instruction I have given, that is called a conditional instruction or a conditional statement. There are several variants of it. We'll start with the simplest. So this is an example of a simple statement. If true or not, do this if true. So if true or not, this is the condition. If it is true, you are supposed to do this. Now, when we move on, we will get a real example. This is just how it's written. I want you to note that it is supposed to have a full colon at the end. And then after the full colon, there is supposed to be an indentation like this. The conditional statement consists of the following. 1, the if keyword. This if keyword, you are supposed to start your conditions with the if keyword. 1 or more white spaces. So there is a space between the if keyword and the other words. This space is used to separate your if keyword with the other words. An expression, a question or an answer whose value will be interpreted solely in terms of true and false. So an expression, for example, true or not, this is an expression after the white space, followed by a colon. After the colon, you're supposed to go to a new line. And then when you go to a new line, an indented instruction or set of instructions, you are supposed to write at least one instruction. The indentation may be achieved in 2 ways, by inserting a particular number of spaces or by using the tab character. So if you want to get this indentation, you can insert a particular number of spaces, this indentation, you can insert a particular number of spaces, or you can use the tab key. But nowadays, Python indents it by itself. If you are using these latest Python versions, they indent it for you. They put the indentation for you. Okay. So note, if there is more than one instruction in the indented part, the indentation should be the same in all lines, even though it may look the same if you use tabs mixed with spaces. So for example, if the Python hasn't indented for you, you can use the tab or space keys. So if you use the tab, just make sure you stick to the tab. And if you use the space key, make sure you stick to that. Don't mix. And when you have multiple lines of instructions, you are supposed to make sure that all lines are indented. Or if you don't do that, Python will throw an error. Okay. Let's take a look at this. Okay, let's take a look at this. If the true or not true expression represents the truth, the indented statements will be executed. For example, here, if the true or not expression is true, this statement will be executed. If the true or not expression is not the truth, this statement will be ignored. And the next instruction will be the one that will be executed. Let's take this other example. In real life, we often express a desire. If the weather is good, we'll go for a walk, then we'll have lunch. So, as we can see, having lunch is not a conditional activity. It does not depend on the weather, but going for a walk depends on the weather. If the weather is good, we'll go for a walk. So if it's sunny and a little bit windy, we will go for a walk. That means if it's not sunny, we will not go for a walk. So if this was in a condition to be executed, and that day it was sunny, the Python would print will go for a walk. But if it was rainy, the Python will ignore this, will go for a walk. It won't execute it because the condition has not been met. And the condition is if the weather is good. The condition is the weather being good. You can see it here. If we said the if is a keyword, and then it is followed by a white space, and then the weather is good is an expression, and then it is followed by a full colon. Sorry, it is followed by a full colon, and then after that, when you press, you go to the next line, and then when you go to the next line, there is an indentation here, as you can see, and then there is go for a walk. This is the first condition. So if the weather is good, this go for a walk will be executed. But if the weather is not good, this will be ignored, and then have lunch will be executed instead of go for a walk. The have lunch is the one which will be executed. Okay. The if statement, conditional execution. If a certain sleepless Python developer falls asleep when he or she counts 120 sheep, and the sleep-induced procedure may be implemented as a special function named sleep and dream. The whole code takes the following shape. So this is just another example. Let's say we have a Python developer that is counting sheep. And then the Python developer falls asleep when he or she counts 120 sheep. So after 120 sheep, the Python developer falls asleep. You can execute that condition like this. If sheep counter is greater than or equal to 120, sleep and dream. So the first one is used to evaluate is the condition. So the condition here is that the sheep is supposed to be greater than or equal to 120. So if the sheep is less than 120, let's say the sheep is 115, the Python, the sleep and dream won't be executed. It will be ignored until the sheep is 120 or 121, and then this, is 120. And then this sleep and dream will be executed. Or it's 130, it's greater than 120 or equal to 120. This sleep and dream will be executed. As you can see here, the comments tell us more about the code. As we said, the first one evaluates a test expression, and then the second one executes if the test expression is true. We've said that conditionally executed statements have to be indented. This creates a very legible structure. This creates a very legible structure, clearly demonstrating all possible execution paths in the code. Take a look. For example, if sheep counter is greater than or equal to 120, make a bed, take a shower, sleep and dream. And then if it is not, feed the sheepdogs. Here, this shows the multiple conditions the multiple lines of code that will be executed if this condition is met. So if, let's say, we have found that the sheep are 125, this make a bed will be executed, then this take a shower will be executed, then this sleep and dream will be executed. But if the sheep counter is 115, all these statements will be ignored, and then feed the sheepdogs is the one that will be executed. Now, we are going to do the if-else statement. I hope you are understanding. Eugene, so far, do you have a question?
No, I'm following through.
Okay. Yes, now we go to the if-else statement. We started with the simple if. We started with if the weather is good, we will go for a walk. There is not a word about what will happen if the weather is bad. As we have said, we just said that if the weather is not good, we will ignore that, go for a walk. But there is nothing that says if the weather is bad, what we are supposed to do. For example, here, if the weather is good, we'll go for a walk. Otherwise, we'll go to a theater. Or we can say if the weather is good, we'll go for a walk. Otherwise, we will stay indoors. That is a statement that has two conditions. It shows us that if the weather is good, we are supposed to go out. If the opposite happens, we will stay inside. Now we know what we will do if the conditions are met, and we also know what we will do if the conditions are not met. So to put that into Python code, we use something called the if-else statement. If the first condition is true, execute the first statement. Else, perform the second statement if the condition is false. This is how it looks like. It is the same as the if condition. The only difference is now we have a new keyword called else. And after the keyword, we have a full colon, just like the way here during the if keyword, and after the expression we had a full colon. Also here after the keyword else we have a full colon, and then after that we have indentation. Okay, there is a new word else. If the part of code which begins with else says what to do if the condition specified for if is not met. Okay. Now we can say here, if we can, okay, Eugene, can you try to run this statement? Or no, we will just meet labs in front. We will try and do them. Okay, if the weather is good, go for a walk, else go to the theater, have lunch. So by using this form of conditional statement, we can describe our plans. So we have said here, if this condition is met, this one will be executed. If it is not met, this one will be executed. Everything we've said about indentation works in the same manner inside the else branch. So you're supposed to indent the way you indented in the if branch. The indentations are supposed to be the same. And if you choose to use a tab indentation, stick to the tab. If you choose to use a space indentation, stick to the space. Don't mix them. They won't be the same, and Python will throw an error. And then there is something called nested if-else statements. Okay. First, consider the case where the instruction is placed after the if is another if. Nested if is just nested if-else statement is just another if-else statement inside an if-else statement. For example, let's do this example. These are plans for Sunday. Okay, these are plans for tomorrow. Let's say these are our plans for tomorrow. If the weather is fine, we'll go for a walk. If we find a nice restaurant, we'll have lunch there. Otherwise, we'll eat a sandwich. If the weather is poor, we'll go to the theater. If there are no tickets, we'll go shopping in the nearest malls. So this is a nested if statement. As you can see, there are many conditions here. This is if the weather is fine. So if the weather is fine, we'll go for a walk. And when we go for a walk, then we see a good restaurant. Now, if we find a nice restaurant, we'll have lunch there. So that shows this is another condition inside another condition. So if we don't go for a walk, or so if the weather is not fine, for example, if the weather is rainy, we won't find a nice restaurant to have lunch. So this is how it is written. If the weather is good, okay, it is written the same way as we wrote the other if else statements. The only difference is that we have an if inside an if. Here we start with if keyword and then a white space after the if keyword, and then the expression, then the full colon, and then after that there is indentation after the first if statement. And then after the indentation, we bring in our second if statement here. If we find a nice restaurant now, if nice restaurant is found, there is a full colon. And then after that, I want you to notice something. We have also indented again. This indentation stands for this if statement. So it is indented twice here. The first one is for the first if statement, which ends here. And then the second one is for the second if statement. That is why it is indented like this. There is so much indentation here. because we have indented for both the two if statements. And then there is the else keyword. This else keyword stands for this second if statement. Else eat a sandwich. So this else keyword is for this condition, finding a nice restaurant. If we don't find a nice restaurant, we will eat a sandwich. So here, this will be executed if we don't find a nice restaurant. This will not be executed if the weather is bad. I want you to note that this, if the weather is bad, this is what will be executed. Here, this else statement is what will be executed. But if we have not found a restaurant, this is the else statement that will be executed. Sorry, this is the else statement that will be executed. Let those things not confuse you. It can be confusing for a first time, but as you move on, it gets easier and easier and easier. Yes, so else, if the weather now is bad, we have another if statement. If tickets are available, go to the theater. So if the weather is bad and then we find tickets to the theater are available, we go and watch a movie in the theater. Else, if they are not available, we go for shopping. Yes, now this is an example of a nested if statement. Then, here are two important points. This use of the if statement is known as nesting. Remember that every else refers to the if which lies at the same indentation level. So here, every else refers to the if which lies at the same indentation level. Here, this else has the same indentation with this if, so it refers to this if, and this else has the same indentation with this if, so it is for this if. This else is also for this if. Consider how the indentation improves readability and makes the code easier to understand and trace. So the indentation improves readability and it makes the code easier to understand. It has improved readability because we are not confused. We know that this else is for this if. But if these indentations weren't matching, it will be confusing because we wouldn't know where this else lies. Okay, there's also another special statement. There is what we call the elif keyword. The elif is shorter for else if. Elif is used to check more than just one condition. For example, you have multiple conditions. You can use the elif keyword and to stop when the first statement, which is true, is found. Our next examples resembles nesting, but the similarities are very slight. For example, if the weather is fine, we'll go for a walk. Otherwise, if we get ticket, we'll go to the theater. Otherwise, if there are free tables at the restaurant, we'll go for lunch. If all else fails, we'll return home and play chess. Have you noticed how many times we have used otherwise? This is the stage where the elif keyword plays its role. So this condition, okay, this statement looks similar to what we did here, but it is a little bit different. I want you to notice that here we have not talked about if the weather is not nice. These are just conditions. So if the weather is fine, we'll go for a walk. Otherwise, this means that otherwise, if the weather is not nice, or otherwise, if something else happens, we get tickets, we'll go to the theater. So the otherwise here is if we get tickets. This is just another condition. It doesn't depend on whether the weather is nice or not. This is just another condition. If we get tickets, we'll go to the theater. Otherwise, if there are free tables at the restaurant, we'll go for lunch. So these conditions are executed one after the other. The first one is if the weather is good, we'll go for a walk. Elif, this means that maybe the weather is not good, or maybe something else happens. And then there are tickets available, we'll go to the theater. Now, if we miss the tickets, or something else happens and the tables are available, we will go for lunch. Else, if all of these conditions now fail, we will play chess at home. So this is how the Elif keyword plays its role. It is an otherwise. For example, here, otherwise, if something else happens and we don't go for a walk, and then we get tickets, we can go to the theater. Otherwise, if these two fail, if we don't go for a walk and we don't go to the theater and we get free tables, we go to the restaurant. Else, if all these three conditions now fail, we return home and play chess. The way to assemble the if, elif, else statements is something called a cascade. As you can see, they are cascading. Notice again how the indentation improves the readability of the code. You must not use else without preceding an if. So you should not use an else without an if statement. Python will give you an error. Else is always the last branch of the cascade. So else is always the last branch of the cascade. After all those statements fail, else is the last branch. Whether you've used elif or not, else is an optional part of the cascade and may be omitted. As you can see, we have if statements without the else part. We have seen that, so that means else is always optional. If there is an else branch in the cascade, only one of all the branches is executed. If there is no else branch, it's possible that none of the available branches is executed. So if there is an else, if there is an else branch in the cascade, only one of all the branches is executed. So when you practice this, you will get to know it, to understand it well. Yes, so far this is a practice. This is practice for what we have learned. I want you to first go and read so far and understand what we have learned. And then we will continue from there next time. Do you have any questions?
No.
Okay, so please go and read those notes again and understand. If you have any issues, you can reach out. I will try to help you where I can. Also, if you have any comments, you can, or anything you want to say, or your thoughts, you can air them out now.
No, I really don't have any comments, but I'll go through the lesson.
Okay.
And come back to with the question if I face any challenges.
Okay. Okay, so thank you for attending the class. Thank you.